So I welcome you all. I'm Rohit Prajapati. I lead Digital Technologies, and it's a privilege to have you all here today. Considering the fact that it's a holiday, right, and a long weekend ahead. So thank you once again for being here today, and I hope that today's session, right, which focuses on quantum technology. So there is a lot to discuss, lot to share with you, and we also expect good feedback from all of you. So today we have Dr. Ajit sir as our chief guest. I mean, it was a very short notice, and he accepted it, and I'm very glad to have him here today. Thank you, sir, for being here. We are already delayed, so I would just take this opportunity to introduce about Digitode, what we do with academics in India, and share like our journey so far. I'll just take 5 minutes, then we'll start with the session from Harshit. Or maybe I would also request sir to speak a few words maybe after I introduce Digitode.
Yeah, sure.
So we are an 8-year-old company. We started primarily focusing on some small training programs and lab setup programs initially, focusing on embedded applications, embedded systems. I personally come from a background working a lot on embedded systems and working with academics for the last 12 years. So we as an organization, we focus on accelerating the research development ecosystem in India across different academics.
So you to do block, you can come here.
If it's not comfortable, I think you can come here. Okay. So over the last 8 years, we have developed capabilities across 5G, 6G wireless, AI and machine learning. Recently, we started working on quantum technologies. NI's automated test and measurement systems are which we have worked extensively. And we also started working on FPGA and semiconductors, looking into the importance, how they are being widely used across different industrial applications. Yes, I would skip. Okay. So these are the different focus areas that we work with academics in India. So we are instrumental in setting up academic and teaching labs. We also work with research lab ecosystems. We have close to 55 plus MOUs and 15 plus COEs established across different institutions in India. We have, every year we do close to 50 plus workshops, FTPs, training programs as part of our existing lab setups and only focusing on training as well as part of skill development programs. So we have worked with Bajaj for skilling center establishments, close to 8 plus, right? 8 plus we have done so far. These are our engagements with OEMs. We represent different OEMs from different parts of the world, focusing on technologies such as wireless. So we work closely with TMY Tech from Taiwan, and most of you might know about Mantis Web. It's from India, basically based out of IIIT Bangalore. So for quantum, we started working last year in this month of October onwards, and for this we have tied up with QBreak. They have this. We will have a session on that again. So mostly on quantum computing platforms. We are working very closely with QTools. You can see all the setups here, right? We'll have another dedicated session on QTools, focusing on quantum physics and quantum optics. Digilent, we have been working over the last 3 years, 3 to 4 years, 3 years now. And with them, we have been focusing mostly on FPGAs, net-based test and measurement equipment, oscilloscope kind of setups and all. ST, we have been working since 2020. We have set up close to 60 plus labs based on HT technology, which focuses on edge artificial intelligence, AIoTs, and vision AI applications. Probot Technologies is again another company which largely works on robotic platforms on the AMRs, Autonomous Mobile Robotics, and they are based out of Sastra University. Emona Teams is something where we work with them on the telecommunication side, so setting up labs which fosters skills on telecommunication engineering. And VRV Solutions, this is something which we started working last year, and with them we have been working on dedicated platforms focused on network testing and optical testing. So this is our current portfolio where we are working with several OEMs, and there are more plans to add more OEMs to enhance the research ecosystem in India. Largely, we understand that bringing all these technologies at common place, right, working with researchers, faculties, professors will only help us to accelerate the research and innovation ecosystem in India. So this is a glimpse of what we have done so far. I mean, this is an old PPT, so it's not updated with the numbers, but yes, close to 15 COEs, 50 plus MOUs, and still we are on the way. This month, close to 5 more MOUs we are signing. Yes. So that's it. That was a short introduction about Digitode. Once again, I welcome you all. Ajit sir, over to you. Please, few words from your end. Thank you.
Good morning, all. I do not know what to speak because all of us are faculty, so we know exactly what we are supposed to do at the college level, and we go back and what we are supposed to do. So anyway, thank you for the invitation, because today was a holiday for all of us. I thought I will take some family time. Then suddenly yesterday, Anup was actually asking me, will you be able to come here and let us spend some time what exactly we are doing. That's what he was requesting. And then I thought, okay, with so much of enthusiasm, industry is looking at the academicians to give the training to the next generation child. Then why not I should take this opportunity to come here and learn. So because nobody knows everything, right? So we are all learning each other, learning from each other, and also give back to the society by training good things to the students on the latest tech which is needed for the industry. We all know that the quantum space is the new space to the world. It's NVIDIA, when 2008, when NVIDIA started their CUDA programming, I was part of it. And CUDA was developing, that time nobody knew where exactly it was heading. Though the core team of NVIDIA was knowing that there's going to be a real game changer for the data centers, but academicians now they are coming to know that NVIDIA's things are very, very important for the scaling it up of the applications for various different applications, right? So now, if you look back, that particular process or that particular things which I was doing, and I feel very proud in telling that, okay, so I started that GPU-based programming, GPU-based contributions was fantastic. Now, that experience, I can give back and talk about these things to all of us. As a faculty from various universities in Bangalore and various Karnataka regions, we all have a lot of things to be doing and contributing, because we all know that the faculty community has become, we are going deep in terms of understanding about what industry needs. Unfortunately, we have to buck up, including me. I'm no exception. I also have to be in industry's needs, industry's problem to be working with. We all know about recently ANRF grants. They're all asking the faculty to come up with the industry tie-up. Otherwise, we are not going to give fund. It's very clear on those aspects, right? So now, my request to all of you, say, I'm very, very happy that you're also taken some time to come and understand what exactly the industry is doing. So they are all giving you skills, but skills needed for the industry. So that is what it is, a gap which is increasing, and now all of us have taken some time today. Thank you, and thank you very much for us to be part of this particular ecosystem and see what exactly they are doing. So let us learn what exactly they are actually giving to the students community, and see that we'll go back and give that particular things to the students. Thank you very much.
Registered in India. We have 10,000 plus users registered in India, which is more than 20% of our user base. We also have ongoing contracts with IIT Delhi and IIT Patna, and some of the contracts in pipeline, which I think Rohit must have more information on. We are very dedicated to work with Indian universities and institutions, and we provide special pricing and discounts for Indian universities and research universities. Now, moving on to our features, we have some flagship features which I'll highlight in this slide. The first and the foremost is the KubeGrid Lab, right? So I think all of you must know KubeGrid, the Google Colab environment, right? How many of you are familiar with Jupyter Notebooks, like Python Notebooks, Jupyter Notebooks? The show of hands. Okay, some of you guys. So basically, this is like a cloud-based environment which will provide, a Jupyter Notebook interface or a Python interface directly hosted in the cloud. And you can skip the hassle of your cloud and authentication setup. And you will get pre-configured quantum environments which are ready to go whenever you launch that. We also have a very similar VS Code interface for any person who wants to develop and is more familiar with VS Code. And here again, you can choose or forward in 30 plus modern software environments using our VS Code environment manager and other features. Now, this is another very important aspect of KubeGrid. It's called the KubeGrid SDK. So this is a Python package which is completely open source with install. And this is a toolkit which allows you to bridge your code to any quantum package, right? You can basically code in any framework which you want, that is Qiskit or Python or any other quantum computing framework. And you can code it once and submit to any backend which is supported inside the KubeGrid platform. And all of this is done with a single access point with KubeGrid API. So you can also just think about what you want to build, but not how you want to execute on different systems, right? So this is like the USP of KubeGrid SDK. Then we have the KubeGrid runtime, which is orchestrating the back end of your programs inside the KubeGrid platform, right? The quantum hardware. So, for example, if any university, let's say Karnataka, has a quantum computer, right, and they want to hook it up to KubeGrid, that can be done very seamlessly through KubeGrid runtime. And this is our managed API service which we provide for any local or cloud quantum computing environments, right? You can also manage user access. You can also collect device usage for maybe your institution's quantum computer, or you want any other access from any other particular system. You can also do that through KubeGrid runtime. And you can deploy different versions of your software as well, not just hardware, but also simulators are built for runtime. And then this is a very recent update. We have also added the KubeGrid assistant, which is a contextualized AI assistant. You can have very rich context about KubeGrid using something called the MCP servers. And then this will provide a conversational agent as well as an autonomous agent, which you can use to learn tasks directly inside KubeGrid. Now, the exciting part, I'll come to the demo. So, this is what KubeGrid looks like. Okay. So, this is what you see when you sign into KubeGrid. This is our dashboard page, right? And these are all the services, all the features which are available at a glance. I'll explain and go slowly over each and every one of them. So, the tile which you see highlighted here is the dashboards for KubeGrid Lab instance. You could, potentially launch any particular instance for this particular subscription, right? And this will be launched in like a few seconds. You also have a consolidated view of quantum jobs and what kind of usage you have, like compute hours and the storage, right? While that instance launch.
Students and for teachers, as you can see, our devices also are very compact and very robust. We aim, so we focus on quantum physics, phenomena like Hadamard-Mendel experiments, Michelson interferometer, although that's classical one, but we use it to compare classical to quantum. Tomography, cryptography also. And entanglement, of course, we show entanglement really on the screen. For me as a physicist, I find this really fascinating to see, like in a couple of minutes, how the polarization states are entangled, different states of entanglement, the degree of entanglement. And for students, this may be really hard to access first in studies when you only know entanglement through formulas, but here we can show it actually. And our devices mainly are. Second. They are composed of these three main units. The middle one we call the control unit, QEDU, also for quantum education. And this one you can see here, it's based on touchscreen, and it has all the APDs, all the channels that we connect experiments to. And the two other main boards are entanglement demonstrator, ED, and the MV centers. For quantum sensing, we use it to sense magnetic field. The entanglement demonstrator has all also the laser source and all the add-ons that I mentioned, like the Michelson and Helm-Mandel Hanbury twist interferometer. The NV experiment also has its own laser source, so these both has their own laser source. And as you can see, I did my graduate degree in the NV centers. My setup was 2 of this table, and I can perform the same experiment on this board. This is like a genie coming through. We also provide all the manuals, very schematic representation of all the experiments here and on the sheets. You can see how the experiment is working through the connections, all the optical fibers from where to where they are connected, the optical path, all the components are also labeled on the device, and this makes it easy for the teacher to show the students and to make the students also independent. This is the NV experiment, also a schematic overview how it's done. This is the education board, this one, and this is the NV center board, this one, and that you see how it's connected. The APDs are here, the output and the laser sources here. These are 4 different add-ons that we have, not all of them, but some of them.
Which one is the NV center apparatus? Can you show us?
This one.
And where is the NV center and where is it loaded in that apparatus? Where is in the device?
Yeah.
Where is the?
Inside the magnetic
Let's say the black colored. That's inside that the diamond has been included, right?
Yes, inside here, the diamond and the microwave antenna.
Yes. And the right hand side, the shiny cylinder, that's the.
This one, the objective, confocal microscopy. We focus the laser, we use nanodiamonds, and we focus the laser on the nanodiamonds. And you can see on the board a live view how the diamonds are scanned. Like you can see the red dots as the nanodiamonds.
And where are you detecting that the result of the spectroscopy is being detected? Where can you show in the box?
When
you're sending the laser light, right? You're focusing it on the diamond.
Yeah.
And then the light that is coming out, where is being detected?
On the APD here, on the QED. So the laser source is here, but the optical fibers are connected to here. Here are these APDs, yes. Yeah.
So basically, it's like a data acquisition device.
Yeah.
The time takers can detect the photos and visualize, give the visual image.
So it's a control source, control unit, and it also analyzes the data, and it has the sensors for the experiment.
So I might be getting this wrong. You are transferring optical signal into digital signal to monitor its results.
Yes. Yeah. It has also its own FPGA, and we will show you also later. These are the 4 different kinds of add-ons that we have, not all of them. This is also another device that we have, QDisc, for measuring time and distance very accurately in picoscale. But this one we don't have here. This one we don't have here. So we're focusing today only on the quantum education kit. Any questions?
A lot of questions are there.
Yes, sir.
We can come back.
Yeah.
Yeah, so now I'm telling you everything.
How they work, we will show you now.
I think service.
In entanglement, you are showing some people related to entanglement, right?
Yes.
So here just how formation of entanglement is happening, or if even if we change the entanglement like distance between the two, like the entanglement exists like that only. Is it
I can't
formation?
hear you very well.
That is asking.
Yeah.
So entanglement for
Yeah.
how much time it will be? That are you able to show?
You mean for how long it can be preserved the
How
entanglement?
long it
So
will be
yesterday we
entangled.
performed, so you know CH/SH inequality?
Yes.
So to verify the Devel inequality,
Yeah.
it was 2.6 we measured yesterday, and after maybe 10-15 minutes we performed the experiment again, it was 2.5. So 0.1.
It's a long lived.
Yeah.
T1 scale.
Yeah. So it's pretty robust. As I said, it's for mainly for education, but we also are working on it to make it also more research friendly in the way that we make our devices modular. So still compact, but to make it more modifiable. But for students, it's also useful when they are like this compact and very robust. Like some wanted they are like this, some wanted to change them, like to make them more customizable. But depends on the purpose.
Question. So, in IITs, there are supercomputing infrastructures. In the supercomputing infrastructure, quantum entanglement data production takes nearly 3 to 4 months. These devices are performing quantum entanglement experiments. Can we capture the data in real time?
Yes.
Capture the data in real time, like to see the entanglement data, and then they
No.
can.
The capture the data in a format so that it can be used
Yes.
for computational simulation.
Yes.
We can do that.
Yes. So if for a certain experiment you want to have for example, a magnet interferometer, you have the interference fringes and you want them.
Yeah, those parameters from the
Yes, you can extract as a JPG file, JPG, and also the text file.
Okay.
Yeah.
How many bits it can take, like the hardware?
This, we asked. So it has its
How many
own storage.
qubits?
Yeah, qubits.
How many qubits till entanglement it works like?
2 qubits. 2 qubits.
2 qubits.
Yes. I thought like the storage. You mean the storage of the device? I don't think.
No. How many qubit entanglement can be experimented?
2 qubits. Polarization states. Yes.
Are we able to identify the particular NV centers using this? Like various type of NV centers in the diagram.
Different types of NV centers. Yes.
NV0, NV minus, NV plus, we are having that.
So different samples. Yes. We
Not
have
different circles. Not about different circles. In the diamond, we have a various of NV centers.
Yeah. I understand what you mean. So now I have 14 isotope nitrogen. 14. All the 3 nanodiamonds have 14 isotope. But if I want to put like another sample, this is what I mean, another sample with 15 isotope, I can also put it. This we discussed also. We can change the sample. This is what you mean?
Is there only one NV center in the diamond?
One second. Yeah.
Same question.
Yeah.
In the diamond, you have only one NV center or different types of NV centers?
No, this one only has one type of NV center.
Only one NV center.
Yeah. But three different nanodiamonds, but only one type of NV center, yes.
For example, I have 2 diamonds. In one diamond, NV center is in the state of NV0. Another diamond, NV center is NV minus state. Can we identify these 2 states?
So, for me, I don't see the problem except that changing the sample itself. The laser is the same laser. I just change the diamond, right? And maybe the microwave frequency would be different, but the range is pretty large. The microwave frequency that we have. So it's applicable. I think it's no problem to put that sample. Like what I mean by sample is putting something like NV0 and NV minus. Yeah. Yes.
Same question.
Yeah.
Can we replace with other diamond with other NV
Yes.
center?
Yes.
Is possible? Is there any flexibility?
And this one, it's
In
not.
the same provision, can we replace one more diamond?
Yeah.
Is there any calibration method in that?
I think we have.
Asking whether the diamonds
Yeah.
can be replaced with Understand.
Not in this
Yeah.
one, but we work with
Science.
not in the setup itself.
If you know how to build a device and if your technology device can integrate the device, if the answer is yes, you can do it.
But with not the same device, maybe if you require your samples to be introduced in the we can do it. But not, let's say, in a device here, I cannot pick out the diamonds.
Yeah.
But if you want, you have some diamonds grown, some samples, you want to place it in this, it's possible.
Now you are using green laser. For that green laser, they optimize the diamond.
Optimize
I think it's
red center is meant for 560 nanometer. If you change the diamond, then accordingly laser light source also we need to change. Not required. That is micrograms.
the laser should
Output
the output would be different. Yes, exactly. And then the green laser should be the same.
Can we move on to the demonstration?
Yes.
Yeah.
The third one is the count rate of the second APD, and the middle one is the coincidence between these two. So now we try to, because we want to perform the entanglement experiments, so now we want to aim for coincidences. So we want to get high coincidences, and they have to be entangled.
So,
if you,
by the way, this middle graph is a coincidence curve.
Yes.
For that, you have used your time table circuit. The time table circuit.
Yeah, it's inbuilt in the device. Yes. So there are the coincidences are shown. So for example, if you run a Michelson, you don't have to perform now the steps because you just use one arm and they don't have to be entangled. But for example, if you do the Bell experiment, we want to do now, we have to aim for high coincidences and they have to be entangled. So now I try to I do beam walking. We call it beam walking. Yeah, so because you also have to change the angle of the light, so I just take one axis for alignment, and then I turn one of the screws, and I follow with the other one. So that's what I'm going to do now. So now I change the polarization, also the half-wave plate to 45 degrees, and then I switched both polarizers to plus. So now to look if they have pretty good aligned already. So now we want to see that we have a good entangled state. So we switch the polarizers to 1 to plus and 1 to minus. And then we look at the ratio of the counts, of the coincidence counts. And we want to aim for a ratio, let's say 1 to 10. So if the one polarizer is plus and one is minus, we look for really low coincidences. And if they're both at the same state, we look at really high coincidences. So now it's PM, so one is plus, one is minus, and we have 600. And if we go to BP, we have around 9,000. So it's already pretty good. And then, yeah, we can move further to the next experiment. So here we want to show the entanglement between the two paths. And we have a screen over here. So when I turn one of the polarizers continuously, it shows the count rate. So it shows the angle of the polarizer that's turning continuously, and the radius of the counts is the radius of these points is the count rate. So if it gets more, it gets bigger. If it gets less, it gets smaller. So now we just see a circle. But here you can change between what signal you want to see in there. So at the moment we are just looking at one beam, but we want to see the coincidences between these two. Oops, what was that? Okay. So if I switch to the coincidences, now it's the coincidences between the two paths. You see this shape. Want to explain?
Excuse me, sir, ma'am. Can you just take 5 minutes of your time? Can you take your seats or you can stand? This is the last solution which we offered from VRV Solutions. So it's an USA based company, and we have last year we have collaborated with them. So it's VRV Solution. So they are known for their optical fiber characterization, optical testing, measurement solutions. So if I give an example, like if you have a QKD Alice and Bob setup and you want to test the communication channel between the Alice and Bob, so you can use the platform from VRV, MAP, which is a MAP 300 platform, modular application platform, and you can use the platform to test the QKD link basically. So this is our, like if you want to set up a testing lab, you can go for this solution. You can do various experiments, QKD link testing, network testing and all with these MAP platform. So these are this is the MAP 300 platform. I'll just show you. Yeah, and these basically the MAP 300 platform has chassis. So you can plug and plug out the chassis. It comes in a modular cassettes. So what are the cassettes? Based on your application, you can choose these modules basically. So you will be having source and amplifiers, spectral analyzer, signal conditioning modules, switching and routing modules. So all these modules based on your application, you can plug and play in your VRV's MAP 300 platform. Then if you are basically looking for quantum based testing platform, then you should use these yellow colored modules for your quantum QKD testing application. Then this is for MAP 300, you have 3 variants. One is your 3-slot chassis and one is your 8-slot chassis. So this is your 3-slot chassis, which is MAP 330, and the 8-slot chassis is MAP 380. And basically you can see the MAP 300 is placed. This is a live setup which is done in a Singapore lab. So they have done a setup for quantum safe network where they have placed the MAP 300 in the entire setup. And so I'll just show you, this is one of the use cases which can be performed using the MAP 300 application. So you will be having the QKD Alice, the transmitter, the Bob receiver, and you can link with the source module, with the filter, so tunable filter module, you can, based on your application, what use case you are working on, you can put it and you can perform the QKD link testing. This is one kind of thing.
Can you go to the slide?
Yes.
Like, where is E in this architecture?
No, this is only for just to take the basically like the path interference basically. They are not introducing eaves here. They're just testing. See, here is like change the noise and attenuation level condition of the interference signal, and to to see what is the difference between the classical channel network and the QKD's channel network.
Can you take a picture of this?
Yeah, sure. You can, we have the brochure outside also for this.
But I took the brochure, it doesn't have this.
No, this is there, sir. This one is, some of the use cases are there. And if you want any details further, we can send you the proposals or brochures regarding these use cases or experiments. So this is the output, basically a Mount Fuji. They tried to create a Mount Fuji, and like we had a last meeting. They were like, we are planning to build a Taj Mahal because most of the Indian customers are telling, can you build the Taj Mahal out of the configuration? So, and this is one more quantum network link signal power conditioning effect. So same, you can, whatever modules you can take, one is your attenuator, the splitter, which will have it in 10 by. No, it's like by this application gives you this result basically, the Mount Fuji filter they are trying to make, like they made it because
Mount Fuji is the name of the filter.
No. Like this is the Mount Fuji which is in Japan. So they tried to make in that structure.
But that is to test the link, right, between allies and
yes,
right?
but it came has a similar structure. So the name.
Okay, you mean to say there's no tampering, and then is it something like that, or what is it you're trying to convey?
No, basically.
No, what is the benefit of making Mount Fuji here?
No. Basically, they were getting this output. Okay. Yes, so they were getting this kind of filter. So they named it as Mount Fuji filters.
Madam, what is the y-axis and x-axis?
It is power is to wavelength.
Okay.
Yes. So now the Indian customers are telling like the Mount Fuji you have created. So can we get a Taj Mahal also? So that was the scene. So this is another use case, quantum network link signal. So here also you can, so basically the idea is the MAP 300 platform, you can have whatever modules you want, the source units, the tunable filters, your power meters, spectrum analyzers, anything you can have. And the working wavelength of this module is C band, L band and O band. O, C plus L also. So these are the three bands which these modules are working on. And the VRV solution also have cleaning and inspection equipments. Basically, if you have a optical lab setup and you have some optical cables, optical fiber cables and all, so you can clean that cables as well. You can see what are extra particles or basically cleaning and inspection purpose also. The applications are there based on these. I don't have a picture of that, but yeah. So basically, I have to find where is the distinct picture. So you will be having cleaning and inspection based hardwares also. We also have network testing, ONT 800, which is a ONT for traffic generation testing and all. And so these are the mainly known solutions from VRV. VRV also has wireless and wired solutions. So if you want PQC side of the solution, so they have a TerraVM platform where you can implement your PQC validation as well. So, and QKT testing, you have seen it by MAP 300. So these are few solutions from VRV solution. And if you want any details, more detailed explanation, we can share you the necessary documents. And I hope you liked the session, and it was an interactive session as well. And if you have any further doubts, queries and all, we can contact, and we can visit to your colleges as well. And so I'll just call